I started off my genomics career at the Whitehead Institute back at MIT. So this is a center in Cambridge that was sequencing the human genome and was part of an international effort to sequence the human genome along with the Sanger Center and a few folks in Japan and Europe. That was from 96 to 2000, and I was managing their research and development team there. So we built a lot of the robotics that automated the DNA purification and got the sequencing running there. And in 2000, when that project was coming to a close, I decided to spin out a few of the patents that we had acquired at the time there into a company called Agincourt. And this was a private entity that was a DNA sequencing provider for a lot of people in the pharmaceutical and healthcare space. But we also sold DNA purification tools that help people extract DNA out of cells. And fast forward to 2011, 7 years in that time frame, the company also built a DNA sequencer known as a solid sequencer that eventually went to market under Applied Biosystems. They were for those in the sequencing field, they probably know of maybe two companies that have had fairly large market shares throughout the history of DNA sequencing, and ABI was the first one. They had all these Sanger sequencers, and they have they're still in the market and they still do their thing under the Thermo name. But there's now Illumina, who's a very large contender and arguably a larger entity now. And we were competing with Illumina with the solid sequencer for a period of about 5 years. And then in around 2011, I decided to just do something different and get out of the industry and go into the plant genetic space. And we began sequencing cannabis genomes back in 2011. Flew over to Amsterdam and extracted a bunch of samples over there, met Don and Aaron from DNA Genetics and Dave Watson and a bunch of other, Robert Clark, a bunch of other folks showed me around over there. And we really didn't know what to do with it at the time. We just knew that genomics helped so many other markets. It was bound to help this one, but we had no idea what to do with the information and how to turn it into a company. So we kind of explored a little bit. And I'd say it was a very slow start with medicinal genomics because we were a company that was embedded inside of a clinical diagnostic company known as Cortigen. And most of the company's efforts were sequencing kids with epilepsy and mitochondrial disease, and arguably a lot of diseases that center around the ECS. Although the people in the clinical sequencing space probably don't know what the ECS is yet.
Right.
They're, as you've probably heard from many of the guests you've had before, it's not really taught in medical school. So that was an interesting business, but a very challenging one because as insurance companies moved into the space after the AMA, they didn't like this idea of sequencing for idiosyncratic diseases, diseases we don't really understand.
Yeah.
They don't want to reimburse for that. And so they started raising people's deductibles and making that type of sequencing very difficult for people to do. And that's when we decided to shift the company fully into sequencing cannabis genomes because we saw, ironically, less headwinds, regulatory headwinds in the cannabis space than in the clinical sequencing space. So if that gives you any sense of the background, I've wandered from research sequencing to clinical sequencing all the way into what people might call recreational sequencing, but always has DNA in the thread.
And what is it about working with genetics and studying DNA that really draws you in, that you find really interesting?
Well, personally, I like the fact that it reveals how different everybody really is. I mean, we have this societal tendency to want to group people into either races or sexes or these other large categories and treat the entire population as one. And what we're learning from the Human Genome Project is that is incredibly stupid. Everybody's very, very different and unique, and personalized medicine is clearly the way to go. And it's just taking time to sort of fight the system, to make the system aware of the fact that you're not going to have an algorithm to apply to a population. You're going to need to have physicians actually speak to patients and ascertain that individual's needs. So that, I don't know, that has always been appealing to me, as I generally don't like one size fits all principles. They're just grotesque, and there's a tremendous amount of potential in sequencing people's genomes and improving healthcare. Now that same story really resonates in cannabis because you get involved in cannabis genomes and you realize they're even more different than people are. And this concept of a sativa or a hybrid or an indica is garbage.
Yes, I'm glad to hear you say that.
And so we have to change that particularly if we want the medical system to start to speak this language. They're not going to prescribe green crack to somebody. They're going to want to know terpene profiles, maybe even a genotype, because there's a lot of dark pharmacology, as you heard spoken about before. The chemotypes are great, but they only measure maybe a dozen compounds, and we know there's thousands. And so the genomics is another cheap way of getting at that information. And I think the other thing that's really exciting about the genomics field is there probably isn't a field out there that's moving at a faster pace. When you start looking at the cost declines in DNA sequencing, we've never seen anything like this before. And even in the chip market, where you hear about Moore's law, and Moore's law is slow. It's actually something that kind of gets laughed at in the sequencing space, because we're always held back by the fact that the chips aren't fast enough. And the sequencers are moving at a faster pace than the semiconductor improvements are. So it's one of those fields that forces you to learn about DNA storage and data storage information, whether that be in DNA or not in DNA storage. You have to learn about hard drives. You have to learn about internet bandwidth. You have to learn about chemistry required to sequence these things. So it's very you can't get bored in this space.